Welcome back. So I'm picking up right where I left off. So what I'm going to do now is I'm going to run a factor analysis using principal component factoring and using items 1 through 10. Stata has a few machine language interpretable type commands. So x1-x10, Stata knows that to mean x1 through all the values up to x10. And this gives me the output. Now notice it says more. If I try to do something right now, Stata will have a bit of a conniption. So to get the more, I just hit the space key, and that will show me more of the output until I see the dot command, which is Stata asking for the next command entry, and that's the end of the output. Now, of course, I can scroll back up and look at the output that came out, and this gives me the principal component factor analysis for principal components factor analysis for the first 10 items. Now, at this stage, I just want to show how to get the information in. I'm actually not going to spend too much time talking about this, but one of the options that we can do is look at the so one of the things that we can do, again, is using the drop-down menu, we can actually look at other things. So I'm going to bring down statistics. I'm going to go to multivariate analysis. One of my options is Chromebox Alpha. Okay. I want to look at variables. Let's see, I think my commands say x1 to x9. I'm actually going to drop the 10th one. And under options, I'm going to have it take sign of each as is. So that's, remember with Chromebox Alpha, all the signs need to be, all the questions need to be quote unquote coded in the correct direction. And I'm going to have it do the let's see, let's click list individual inner item correlations and covariances. Okay. So that gives examples of the different commands that you can use. Notice it says more. I have to hit space to get the rest of the output. Now, I'm going to actually have it run alpha x1 through x9 as is and item. And that gives me the following output. A little smaller set of output. So I get the alpha for each item. I get the item with the test correlation, the item with the rest correlation. In other words, that's when the item is actually dropped. And this indicates the sign for each of the values, the number of observations, and there we go. Now, sometimes it helps to actually include the label. So if I go back, I'll select the command from the command line, and I'll add label, and that will just add a label at the end of the column so I can keep track of each of my items. Now, so again, if I were to run the factor for x1 through x9, okay, there's my factor and output. And what I'm going to do now is I'm going to use the predict function to actually generate the predict function to generate conserve, which is conservative, as a latent factor, and it will use multiple regression as an estimate. Here are the actual factor scores, the coefficient weights that were used to estimate the factor score. And if I notice now, I do indeed have a new variable, and I could look at the histogram of that. And there's the histogram of my factor scores. Those are factor scores calculated directly from the principal components factor analysis. Now, structural equation modeling allows us to do confirmatory factor analysis in this case. And the construct that's used here is you say SEM, and then inside of each parenthesis you give the indicator for that particular equation. Conservative, which is not defined, so it's understood to be a latent construct, predicts x1 through x9. And if I were to hit enter, it will take a little bit to do the calculations, but lo and behold, it reports the information that we need for our test. From here, one of the things I can do is I can take the output and say, well, you know what, I'd really like it to actually give me the standardized values because that's more useful when I'm actually looking at information. And this gives me the standardized values so I can assess the weight with which each of these values loads onto my latent construct. And next, we could also have it generate some goodness of fit measures for us. I'll have it report the goodness of fit. This gives us, among other things, the chi-square value for the overall test, but also things such as the AIC, BIC, the different fit indices, and then the residuals, the SRMR, which is sort of a badness of fit measure. Additionally, I could have it generate the modification indices. All of these things are things that we will talk about in class. So the modification indices are indicating that the largest of the values that I see here is 147 and change, which is with items 3 and 4. And lo and behold, what I can do is I can actually add that to my model. So I have conservative. One, I've actually dropped two particular items, 2 and 8, for if you look in the book, there's some information about that. But I'm also telling it that I wanted to add a covariance between the items, the error terms associated with the third and fourth item. And this then will give me a more specific factor analysis. The key between confirmatory factor analysis using maximum likelihood estimation and principal component analysis sort of looks for the best fit, searching all over the place. Confirmatory factor analysis says, nope, we're looking at a very specific structure that we want to make sure is or is not there. Likewise, I could also do a two-factor model. Now, there are a number of assumptions that are built into this. So conservative is based on items 1, 3 through 7, and 9, whereas depress is based on items 11 through 13. It's adding a covariance. And because I didn't say otherwise, it's automatically going to assume that I want conservative and depress to be correlated as a pair of latent constructs. And lo and behold, there's the covariance between those. Again, all I need to do is say SEM comma standardized to get the standardized output, and it's the same information just with standardized coefficients instead. All right, so what I wanted to demonstrate also was some path analysis, because the nice part of structural equation modeling is it allows us to obtain things like the direct and indirect effects. So I'm going to bring in the following file from Stata Press Data. This is actually something that I found directly here. So when I went to example data sets, after doing a little bit of searching, I found that there was a data set that I could use here. But this was the link it actually directed it to. The reason I have comma.clear here is to say, well, if I try to run it without it, it's going to warn me. It's going to say, well, do you really want me to do this? Probably not. I'm not going to bring it in. So I need to actually say, no, I really do want you to clear everything that's there. And if you notice over here, it's actually replaced the data set with the new data set. There's not a lot of information in this data set, but we have information on the respondents' intelligence, different types of aspirations, and a friend reported their intelligence and their aspirations. Now, I'm just constructing a model here for demonstration purposes. So what I'm going to look at is the model that is built as follows. So I need to copy this entire line, which should come in as one solid line. Make sure that it is indeed a single line. Yep. Okay. So this has parental aspiration is being predicted by these factors. The friend's parental aspiration is predicted by this, and friend's intelligence is predicted by the respondent intelligence. So it's always good when you're doing a path analysis to actually draw a picture of the model, and this essentially is the model that I've just typed in using what we call the structural equations. The parental aspiration is predicted by these four things. Friend's parental aspiration is predicted by friend's intelligence, and friend's intelligence is predicted by the respondent's intelligence. Okay. Now again, there's some. I don't want to suggest in any way, shape, or form that there's a theory behind this model. I just wanted to do a demonstration. And I hit return, and I get my output. And it gives me the coefficients for each of the paths that are associated there, and also different measures of the variance. Now, one of the things that I can now do is I can obtain information such as the R-squared values for each of my predictors. So here are the R-squareds for each of the variables that are technically endogenous variables in the model. I could obtain a measure of overall fit for the model that I've just drawn. And last but not least, I can also have Stata generate directly for me the total effects. So it estimates the statistics for the total effects, and I'm going to have it report it as standardized values. And lo and behold, I now actually have total effects for each of my predictors, indirect and direct effects. So I can actually break down the total effects into how much is a direct effect from the variable and how much is an indirect coming through the other variables. All right, again, I know that this was a bit speedy. I'm more than happy to answer any questions, so please don't hesitate to contact me. And I hope this helps give a quick introduction to Stata. Thanks very much. Bye-bye.